Hello everyone. In this video, we are going to solve a CSES problem called permutations. So a permutation of integers 1 to n is called beautiful if there are no adjacent elements whose difference is 1. So you are given the number n, you want to construct a beautiful permutation if such a permutation exists. So in this case, we can first observe from the examples here to see that when n equals to 3, there's no solution. So what about n equal to 4? When n equals 4, what we can see is that maybe we can come up with a permutation something like this. 3, 1, 4, 2. So all the adjacent elements, the differences, are greater than 1. So this may lead into some interesting idea of what if we can construct a permutation that has a difference with a lot of differences with 2, right? So this gives us the first construction, the idea of construction by the formula. So what we can see is that maybe we can, for example, starting from 1, and then we put all the odd numbers to the left hand side. Okay, so something like this. And then we can starting from the largest even number, right? Which is the largest even number. So that's 2 times n over 2, right? And then we can do this and divide by 2, minus 2, and so on. So this ensures that for all the numbers with n is at least, let's say, 4, the gap here should be at least 2, right? Okay, so or at least 3. So in this case, we can ensure that the permutation we construct is beautiful. Let's try to code this idea up. First, we create a new file, and then we read input n, and then we can construct all the odd numbers, right? So the odd numbers are basically using the list comprehension or the arrays, right? So just again, starting from 1 and at most n. If n is odd, then we should include that number 2, and then we skip by like 2 at a time, right? And even numbers are same thing, range from 2 to n plus 1, and we skip the step size is 2. So all we need to do is to reverse the values, right? So we can just say we can say odds.reverse, and then what do we need? We simply need to take that to attach that with an even.reverse, right? So odds.extend, okay. So if n is less than 3, then we should print no solution. Otherwise, we should print out the entire array of numbers. Right? So the simplest way to do that in Python is that we can simply join the entire array, but we need to map that into string, right? Something like this, and we can basically, this is the line, just print the entire line. Okay, so let's try this. So if we enter 3, it prints no solution. If we enter 5, it prints 5, 3, 1, 4, 2, which is a beautiful array, a beautiful permutation. Or in case that we have 4, then it also says. Okay, so let's try this. Takes a little bit of time, and it got wrong answer. Okay, let's see why it gets a wrong answer. So there's a tricky part where when n equals to 1, then there's no like adjacent elements, right? So in this case, if n equals to 1, we should directly print 1. Okay, then this is the tricky part. Let's try it. Okay. Okay, it gets accepted. Nice. So sometimes the construction by formula or construction by this kind of observation may not be accessible during a programming contest. So in this case, maybe we can try to think of a different way to this problem. Maybe what we can do is to try to construct a sequence incrementally, right? So let's try another idea. So if we come up with a shorter sequence for the smaller n, can we extend the permutation that still satisfy the beautiful constraints? And as we make the n larger, right? So let's start with n equal to 4. We can construct a sequence something like 3, 1, 4, 2. And then what we can do is what do we have if we have a sequence of length n, right? So increase the value of n, we can try to put this largest number to the leftmost position or the rightmost position. So this idea would be the idea that we can have and that constructs the sequence from the smaller value of n to the larger value of n. So what we can do is we start with n equal to 4, and then we alternatively add the next n values to the leftmost position and rightmost position. So let's see. If we would try to add a 5 here, we can add a 5 here and make the permutation beautiful. And then when we add a 6, we can add the 6 to the end of the permutation. And then when we add 7, we do the same thing. When we add 8, we do the same thing, and so on. This is basically what we got. This will be very similar to the previous solution, but the idea is a little bit like different. Okay, so let's try to implement this. So sometimes the implementation may be a little bit, I don't know, like hard to say or something. Okay, but anyway, this is basically the same idea. Okay. Let's try it. N equals to input. So if we have a list, we of course can do like let's say insert from the beginning and insert from the end. But if we have an array, I think inserting from the beginning may be a little bit like not so efficient. So we can still do the same thing. Okay, so we can split the array into halves, and we try to insert elements from both ends. So we can have 2 arrays. So if n is at least 4, we can still have the 2 parts, right? So we can still have 3, 1 as a first half, and we just reverse it, and we have 3, 1, and 4, 2, right? Okay. So, and then starting from values, the next n value, starting from 5 and up to n, right? So if it is an odd number, then we should append to the beginning of the sequence. So we just add that to the first sequence, and then otherwise we just add that to the end. Okay, this gives us the entire construction of both sides. And then what we will do is very similar to the previous solution, which is we just reverse the first half, and then we attach with the second one, right? So And then we just simply output this. So if n is 2 or n is equal to 1, we just print 1. If n is at most 3, we print no solution. If n is at least 4, we just print the entire line. Just map everything to strings. And then we print the line. Okay, let's try this. If n equal to 1, if n equal to 3, if n equal to 5, if n equal to 4, okay, that looks good. If n equals to 100, then it should look somewhat good. Okay, so let's try to submit it. Okay, we got accepted. Nice.